Okay, so here it is here. Here's the sample question. If you want to write down the different things that we're going to find, now you can. We're going to find each one individually, so, I mean, you can do that at that point. We have a ball. It's hit at 53.1 degrees. It's a weird angle. I'll explain why it's that angle. Above the horizon and has an initial velocity of 10 meters per second. And this is a really tall cliff. It's 400 meters tall. So ultimately, we're going to find out where it lands down here. So I'll give you a second to jot that down. I'm going to do my attendance, and then I will start that. Okay, so as in just about every situation, you should begin by finding the two components, VV and VH, of the initial velocity. So let's go ahead and do that. So VV and VH, now do I have them? Come on, tell me I do. No. Got to write them out. Curses. So VV is going to be equal to V sine theta, and VH is going to be equal to V cos theta. And I think that speed was at 10 to begin with. Okay, so we're going to have 10 sine 53.1, 10 cos 53.1. And the reason I chose 53.1 is so that these work out to nice integer numbers. And I can't remember which one is which, but someone will tell me, I'm sure. Should have brought my calculator with me. One I think is 8 and one is 6, I believe. Which one, Josh? VV is 8? I've done these problems a lot, Nate. Yeah. In fact, when I retire, I might just sort of do problems for just, enjoyment at home. Oh, I'll be answering the phone, people looking for tutors.
Really?
Yeah, of course people are going to phone me looking for tutors. Way? No, they will.
Really? No one's even gonna know who you are when we're all.
Nate.
You're gonna be a myth.
I'm a legend. Is this one 6, Josh? Yeah.
Well, like in grade 9 and stuff here, like maybe the kids do actually bet you.
Yeah. Yeah, they won't care about me at all. Who's that old bonehead, right? Like,
3 years
yeah.
of students will come to.
You're right. You're right. I hate to say that, but you're right, Nate. Okay, so we got VV is 8, VH is 6. They're nice round number or nice integer numbers. That won't happen all the time. It's just sort of a thing that when I got this sample, that's where it came from. So, anyways, time of rise. Okay, so it looks like this. Now, again, time of rise, we're talking about vertical. So what's important is the vertical component, which was 8, right? So our VI here is 8, and we know at the peak right there, right? What's the velocity? 0, right? So the VF for that little interval is 0. The vertical velocity is 0. It's still traveling sideways, right? So the we've completely separated VV from VH. Okay, so VF equals VI plus AT, 0. VI is 8, acceleration minus 9.8, solve for T. T is going to be 8 divided by 9.8, right? Actually, technically, it's minus 8 and minus 9.8. So some number about like 0.8 or so. Sorry, no calculator with me. That's fine. 0.82? Okay, let's go with 0.82. So 0.82 seconds, 82 seconds to get to the top. Now, yesterday, when it was flat ground and the vertical displacement was 0, the time up was equal to the time down. But clearly, the time down is going to be way more than that, right? Obviously. Okay, so we'll deal with that in a bit. Now it's asking for the height of rise. So this D right there, right? Couple ways to do it. You could go VF squared equals VI squared plus 2AD. I prefer, because it's going to give me D equals VIT plus 1/2 AT squared. 8 times 0.82 plus 1/2 minus 9.8 times 0.82, and I got to squeeze it in, squared. Sure, that's a good idea. Nate, you be the official calculator. Does the minus 9.8 matter here? Oh yeah, huge. Huge. Sorry, Matt, because the 8 is positive and it's up, and the acceleration is slowing down, right? So if I put positive there, it's actually like it's increasing in speed, and it's going to go forever. No, because this is the displacement it would go if it was at a constant speed, but because it's slowing down, this is how much you have to subtract. So yes, negative is important. That one for me, Nate? Okay. Has someone else? I don't take this by offense, but as Josh, okay, I kind of would like two numbers, two confirmations. Yeah. So only 3.27 meters up. Okay. No, it's not going. Well, it was only 10 meters per second. Isn't very fast, really, right? Like that's, 3 meters is, well, you're right. It's not very far. Actually, it's only 8 meters per second up, right? It's not 10, it's 8. Okay, am I good to go on? Total time of flight. Is the time up equal to the time down? No. Okay, now there's two ways to do it. We could, and I probably will, because I'm going to show you both ways. We know, and this is not to scale, I'm just leaving myself some more room, right? We know the time to the top. We know the distance to the top. Could I figure out the time to fall that distance? Absolutely, right? What's this distance here? 3.27. This is 400, which makes this 403.27, right? And the VI is actually right. Well done. I need to find time. So D equals VIT plus 1/2 AT squared. Does it have to be minus 403? Yep, because it's down. Anytime there's sort of things going in that opposite, right, you have to sort of deal with it. So 403.27, and I'm going to run out of room here. 0 is my initial velocity. 1/2 minus 9.8 down, t squared. So minus 403.27. Half of 9.8 is minus 4.9 t squared. And I'm thinking you can do that. Divide by 4.9 and take the square root. And I'd like two different confirmations again. The number count? 9.07? Yes? Okay, good. Thank you. Now, is that the total time? No, because we didn't add that. We got to add that total time at the top, right? So T, I'll put big T there. 9.07 plus, what was that number? 0.82. Ooh, I might be able to do that in my head. 9.89. Right? Okay, how many steps did that take? Well, we had to find the time of rise, had to find the height of rise, then we had to do the adding, which really wasn't that hard. We could do that in our head, and then do this part. Right? So really 4 steps. Is there another way, sort of a more elegant kind of, I'm a smarty pants, kind of a cocky kind of, I can do this with my brain kind of way? The answer is yes. Do I have it on a blank page here? No, I don't. I'm going to do that for you. Okay? I'm going to do that. Quadratic formula. Yay! It's the reason why you learn quadratic formula, just so you can do this. And it kind of makes me feel good that I can do it, and I like to pass that on. Okay, so what is the overall displacement? Minus 400. I'm going to go D equals VIT plus 1/2 AT squared. What's my overall displacement? Minus 400. What's my initial velocity? Yes, 8. 8 is the vertical, right? Because we're talking about from there, from the launch spot to the bottom. So we're talking about this whole flight. So it's being launched at plus 8. Yes. This is actually going to work out to, what would you expect this to work out to as an answer? 9.89? The 9.07? Okay. Okay. Just keep that in mind as we go forward here. 1/2 minus 9.8 t squared. We're going to get a quadratic for sure. Let's make our t squared positive because no one likes negative, right? So this is going to be minus 4.9. I'm going to take it to the left. 4.9 t squared. The 8t is going to go left and become minus 8t. And the minus 400 is going to stay there. Equals 0. And Billy was right. Quadratic formula. Or quadratic anyways, right? Not like, is it factorable? Of course it is. Do you want to do it? Nobody does. Quadratic formula. I'm going to give you the added bonus feature here. If you have a quadratic function solver on your calculator, you go right ahead. If you have something, if you have Desmos or you have some kind of quadratic thing, or even just an app that some nerd wrote that solves quadratic formula, you go right ahead. Because I'm more about, can you use it? Okay? If you don't, well, you're going to have to go with good old quadratic formula. So it's going to be x equals minus b, so that's going to be 8 plus or minus square root, b squared. I was b 8. Can I write just 8 squared? Do I have to write minus 8? I'll write minus 8 squared minus 4ac. A is 4.9. C is minus 400 all over, 2a, 2 times a, You guys seen Desmos in math class? Yeah? Did you? What was it? 4.9 x squared minus 8x minus 400. Did I get that right? 9.89. No. In fact, what it gives us is this one here. Well, because I forced you to do that, right? If the only question was, what's the total time of flight, that's a two-step question. Especially if I allow you to use a quadratic solver here, right? I like this because this is sort of the, I'm smart and I know how to do this. This to me is the more brute force kind of do it in chunks. So this one makes me feel smart, so I like to do it this way. Whether you get that feeling or not, I don't know. Yeah. Okay. So there's our answer. 9.89 is the total time of flight. What's the range? How far does it go? Well, that again is always going to be VH multiplied by T. Horizontal was 6, I think, right, from the start? It stays the same. Does the 400 matter? Not now, because we got the total time, right? All we know is that it's traveling sideways at 6 meters per second for 9.89 seconds, a little under 60. 59 point something, I'm guessing, right? 3, 4? Is that the last question? Is that the last part to do? Or does it ask for it asks for velocity to impact? Okay. So the velocity to impact, again, is a combination of the horizontal and the vertical. Is it not just 6 and 8? No. It's 6, but the VV has changed dramatically. In fact, it was 8 plus 8 before, now it's negative, right? We don't know this value here, but we do know VF equals VI plus AT. Solve for VF. VI was plus 8, up, minus 9.8 time 9.89. Is the negative important? Yep. So 8 plus negative 9.8 times, that's going to be 10, about minus 90 or so. Yeah. Minus, oh yeah, that sounds familiar. 89, is there a decimal count? Okay, minus 89. Close enough. It's going down a whole lot faster than it is going sideways. In fact, in real life, with so much air resistance, it'd be not going sideways at all anymore. Meters per second. That's pretty fast. Right? That's assuming no air resistance, which means it hasn't reached terminal velocity. So now, V squared is going to be 6 squared plus 89 squared. I think you're going to get, for all intents and purposes, 89. $89? Any decimal at all, Josh? Okay. Which means that this angle here is going to be like almost 90 degrees, right? Opposite over adjacent. 89 over 6. About 89.5 degrees or something. Got it, Kyle? 86? Oh, really? Okay. And that would be BTH or Easter Island. Okay, so not terribly hard. Is it a lot of steps? Yeah. Think back, if you will, to grade 11, maybe about the first month of grade 11, and how you fighted me with writing formulas and showing your work and all that. And this was the problem that I was talking about, saying you're going to have to. For those of you that had me, anyways. Okay, here's sample number 2. Now, technically, this is not off a cliff. So, I don't know, do you want me to do this one, or do you want to try it yourself, or why don't you try it yourself? Give it a whirl as a group. Stuntman attempts to jump 40 buses using a 40-degree ramp. His speed is 130. Each bus is 3 meters wide. Will he make it? Okay, so I'll just draw you a quick picture. So you got the ramp here. 40 degrees. You got some buses here. There's 40 of them times 3, so I guess that's just 120 meters, right? So is he going to travel 120 meters? You guys give that a roll. I got to run and talk to Mr. Elf for a minute, and then I'll be back to do that. Yeah, I know. You were listening, Nate. Okay, first step is to convert that 130 to meters per second, right? So 130 divided by 3.6. Somebody help me out. 36. 36.1 meters per second. Then you got to find horizontal and vertical components. So VH is going to be 36.1 cosine 40. VV is going to be 36.1 sine 40. Help me out if you would. Okay, and those are both meters per second. The overall, do we want to do this sort of the elegant way? I like doing it that way. The overall vertical displacement is 0, right? Oh, that's not how I did it here. It was there. The overall vertical displacement is 0. D equals VIT plus 1/2 AT squared. That's that what you got? $27? Okay. Yeah, speak up if you don't get it, you guys. Are you in radians, Mitch? 27.6? That's this one? $27.6. 0.7 then. VV? Okay. Overall vertical displacement is 0 because the motorbike goes up and then comes back down to the same spot. Cole has a question? Thanks for saying that. The VI is this 23.2. T 1/2 of minus 9.8 T squared. So 0 equals 23.2 T minus 4.9 T squared. Now you could go and do quadratic formula if you want, but that'd be silly because this is definitely factorable. You factor out a T. So 0 equals, I need some more space. Factor out the T, and then you got 23.2 minus 4.9 T. So either T is equal to 0, the vertical displacement is 0 before he starts, like when T is equal to 0, which doesn't make any sense. So T is equal to minus 23.2 over minus 4.9, and that's going to give you somewhere around 4 seconds or something like that. You guys may not have done it this way. 23.2 divided by 4.9. 4.7. That's the total time of flight. We're going to use D equals V times T, VH times T to find the range. We're going to use D equals V times T, VH times T, right? Because it's a constant horizontal, which was 27.6, times our time of 4.7, and that is around 100. Oh, it's close. No, 27.6 times 4.7. 129. He makes it by 9, almost 10 meters. In fact, he's probably overshot the ramp. Oh, yeah? Oh, you assume that was, yeah. Yes. That's a fair assumption if you get that, right? But, yeah. Okay, so, yeah, in fact, he more than makes it, right? Yeah.
What if it was second? Think he did it?
I mean, do I care with the answer, will he make it or won't? This is the number I'm really looking for, right? So, alrighty. So, if you want, I'm going to stop talking. You've listened to me plenty today. There's one more sample question you can do here if you want. And you can try this one. You can do some more. There's a couple of these in the problem pack as well. I'm going to stop talking.
I don't want to deal with that.
Whatever. You guys use the last few minutes of class as you see fit. Tomorrow we will have the lab equipment and we will do actual predictions and see whether they land hitting the target or not.